So now we are going to discuss the knapsack problem, and in the previous tutorial we have already discussed about the greedy algorithm, and we have seen how we're going to optimize the sub problems to reach the optimal problem, or you can say the optimal global problem. So we are going to solve the local problems, we will optimize them, and the global problem will get automatically optimized. So let's see this knapsack problem here. This problem says that given a set of different items, so let's suppose you have some different items and each of these item has some associated value and weight. So let's suppose we have some items and we're going to associate it has some weight and some value. So now what you're going to do is, the problem says that determine which items you should pick in order to maximize the value of the items without surpassing the capacity of your backpack. So I'm going to use a very good example here to tell you this, how knapsack problem can be solved using greedy algorithm. So here is an example of a thief. So let's suppose the thief has a bag, or you can say a sack, which has a capacity 50. I'm not assigning any units here after this 50, like it can be 50 kg or something like that, but we are assuming that the sack has the maximum capacity of 50. So we know that this thief is greedy. So what he's going to do is, let's suppose there is a house which has diamonds and gold and some cash in it, and here are the values by you can see the values of each one of them and also the weight associated. So now the thief, since thief is greedy, now thief wants to maximize the value of the items without surpassing the capacity of the backpack. So he has a limited backpack and he wants to fill these three items in such a manner that he will get the maximum value. So that's the evil idea. So in the greedy algorithm, what we are just going to do is, we're going to choose an local optimal choice. Not we, obviously, the thief will choose the local optimal choice. So the local optimal choice says that what the thief is going to do is, he will use a strategy that he will choose the item. So choose item with maximum value by weight ratio, with maximum value by weight ratio. So let's take out the value by weight ratio in all these cases. So in this case you can see that the value by weight ratio is 5. In this case it is 6, and in this case value by weight ratio is 4. So what he knows, what the thief knows, is that these are the value by weight ratios. So basically I'm just assuming that the value of weight by weight ratios are according to these values. So he will calculate the value by weight ratio, because this is the optimal choice. If he wants to get the maximum value, he will choose the item which has the maximum value by weight ratio. So first we know that the gold has maximum weight by value ratio. Then what the thief is going to do is, he's going to pick up all of the gold such that it does not exceeds the capacity, and since the house is having only 10 units of weight of gold, what he is going to do is he will just add the 10 units of gold. So I'm just going to write here 10g. So he will quickly add this 10 units of gold in his backpack. So now the remaining capacity is 40. Then he will choose, he is again going to make an optimal choice. So he will choose diamonds now. And what he's going to do is he's going to choose the weight. You can see weight is 20 and it is not going to exceed our weight, which is 40. So he will add all the diamonds in his backpack. So now the capacity will remain 20 only. So he will add 20 units of diamonds. I'm going to write D here. So now you can see that the capacity of the backpack remaining is 20 and there is some cash remaining. He has picked up all the diamonds, all the gold with all the values here, and he has made an optimal choice. You can see that the value by weight ratio will lead to a global optimal choice. So he will have a maximum value of the items, and the capacity of the backpack should not be greater than. So now we have 20 remaining capacity. So what he's going to do is he's going to take some part of this cash in the backpack. So some part means the fractional part. So we can also call this problem as the fractional knapsack problem. So only if we are allowed to choose the fractions of some items, because there will be some items which cannot be fractioned. You cannot take some proportions of it. So let's suppose we say that now we're just going to take 2/3 part of this weight. So he's going to take out the cash and he will fill the cash with the remaining capacity 20. So he's going to add weight with value 30 into 2/3. So we will pick up the 2/3 ratio of the whole weight, which you can see is 20. So C is going to represent cash. So this result will be equal to 20, which is the remaining capacity of the backpack. So this is this one is the local choice, this one is also the local choice, and this one is also the local choice. After you have made all the local choices, what you are going to do is you are going to add all the values of these items. So 10 units of gold has value 60, 20 units of diamond has value 100, and 2/3 of the weight, that means 2/3 of the value. So 120 into 2/3. So this will give us 240 as the weight. So 240 is the maximum value of items which this thief can take without surpassing the capacity of the backpack. So this is how greedy algorithm works. This is the best example to illustrate the greedy algorithm as an strategy to solve the knapsack problem. So in the next tutorial we are going to study the Dijkstra's shortest path algorithm, and we are going to use the greedy algorithm to find the shortest path from given node to another node, and we will use the local optimal choice. We will see what will be the local optimal choice is, and then we will solve this problem. So thanks for watching.